All right. So my plan, if you guys remember, was to assess Part A next week on Monday. But looking at your work from this practice assessment, I think you guys need more time. There's also people that have been away as well. So something to keep in mind is that we are, unfortunately, with all the interruptions from term one, with all the various absences and things like that, we are quite a bit behind schedule. I would say we're probably almost like a month behind schedule where I want us to be in the curriculum. So yeah, it's not great news. So we have to have this fine balance between pushing ahead but assessing when you guys are ready. So I'm making these tough calls on when do we push ahead and when do we stop and have you guys like do some more processing time. Do you guys understand what I mean by that? All right, and I know you guys are feeling really overwhelmed by your subjects as well, because I can see you guys working on biology and chemistry class. I'm going to call you guys out on it. I see it. Okay, it's not a bad thing because I understand trying to multitask, but here comes the rain. I understand you guys are trying to multitask, but sometimes there's the right and the wrong time to multitask. And I think, have I said this to you guys? All right. There's the right and the wrong time to multitask. It is fine to multitask if you're doing multiple activities that don't require a lot of your attention. So for example, I will listen to like TED Talks on education while I'm making dinner, because neither of those two things require my full attention. Yeah? But when you guys are working on your biology assignments in chemistry, both of those require your full attention. You cannot split your mind two ways like that. And what's going to happen is you're going to compromise in one of the two ways. Either you're going to be trying to listen to me and your biology assignment is not going to be as good, or you're going to focus on your biology assessment and then you're going to miss what I'm talking about in chemistry. Okay? And then you're just going to delay your work for chemistry, and then it's going to keep snowballing and making your life harder. Yeah? So I'm just mindful. I'm trying to teach you that skill set of when to multitask and when not to multitask. And how to balance your workload and how to make that choice. Do I work on chemistry right now, or do I do some biology work in chemistry? One of the things that I want you guys to keep in mind is, can you do it at home, and do you need the teacher help to understand it? Okay? So for example, I do record all my videos, which I know you guys appreciate, and I can see you guys are watching it on my YouTube channel because I can see the views. If you feel like you can watch that video and still understand what I'm teaching about, then I'm not too fussed if you are working on something else in my class, okay? As long as it's working on something else, I don't want you guys like doom scrolling on whatever social media platform you're on at the time. So that's one thing to keep in mind. If you know that you will not understand it by watching my videos and you're going to need to ask me questions and you need that back and forth to understand something, then you need to prioritize listening to me. It's getting dark in here. I don't want that light on. It's too bright. I'm glad they've installed some other lights because I hate that fluorescent one. So those are kind of things to keep in mind when you're working. Obviously, whenever we're doing something practical, you should prioritize that over anything else because you cannot do the practical stuff at home. Ion identification was a weird exception because I had those videos that was produced by my friend Leon, Mr. Soul, who actually works at another school. But most of that's a very rare exception. Okay? So I want you guys to keep in mind we are behind schedule by quite a bit. It might mean that we're going to have to do some compromises within our curriculum, and I do need you guys to be working from home a lot more than what you probably are at the moment. Okay? I know you guys have like part-time jobs and things like that, or like caring for younger siblings, but you're going to have to carve out some time somewhere to do some study to keep on top of everything. We'll see how we go, and I will ask you guys what your preference is when we get to that crunch time between, what we do standard-wise and what you'd prefer. But I'm very mindful that what we're doing will still prepare you for the level 3 course. You guys will be fine to take level 3, okay? So just keep that in mind. This topic here, I do want to teach well because, oh no, it's getting worse. Yay, Auckland, climate change. Yay. All right. After the Auckland floods now, every time it rains, I just get stressed out. I know my house didn't flood, but I still get stressed out because I worried about you guys. Anyway, and I worry about my friend because she had her house flooded really badly. Anyway, so I am mindful that you guys, we're trying to hit that rough balance. And when I did the budget for how many lessons we have, free lessons, that I could delay things, there's only 3 lessons that I can really delay it, and left in the whole year. to make sure I cover all the content that I want to cover. So this is one of the lessons I'm going to use it for because I think you guys are not ready to do this on Monday. I'm also very mindful that the way this assessment is designed is, this is going to be a very boring video to watch. You're not going to see on the screen. Here you go. I'm also very mindful that, that the way this assessment that I have designed is it's not like ion identification where I give you 2 chances. I only can give you 1 chance, and then you have to do the whole thing over again because it doesn't cut as well like ions. So basically, the grade you get on each, the lowest grade, your grade is going to be determined by the lowest grade you get for the section. And so I'm very mindful that if you don't do well in part A, it's going to just, what's the whole point of doing the rest of it, you know? So I want to make sure you guys do know what you're doing and you feel confident with what you're doing. The good news about part A is that if you don't get excellence, you can still get excellence overall because you can make it up in part D. But if you want to get merit, then you need to get merit on this section here. Okay? So that's something to keep in mind when you guys are working. So this is the unfortunate thing about this assessment is that it doesn't have the same wiggle room as the first one. Okay? So just keep that in mind as you guys are working, and that way, like, put this higher on your priority list because of that lack of flexibility. I let you guys put ion identification lower on your priority list because it has more flexibility. Also keep in mind, there's a lot of people that have not given me the essays yet. I haven't had a chance to mark the essays that have been handed in, but do try to get that back to me ASAP so we can update your reports, because I don't think you guys want on your reports saying ends and stuff like that. Okay? All right, so let me break down some of the issues with Part A so you guys are mindful of it. I have given you guys a grade for stuff, so do kind of keep that in mind. This is the teaching version. This is not the one that you guys did, but the same sort of content and some things I'm going to point out for you guys that I saw as common mistakes. So this is just guideline information. You do need to use these information because you're looking to see the pipette sizes and stuff like that. So do read it. It does give you an overall context of what you're doing titration-wise. We're trying to figure out the lactic acid concentration, which is the same in the practice one as well. In the actual assessment, you guys are going to be looking at vinegar and you're going to be looking at ethanoic acid, but still similar. It's a 1-to-1 ratio. Okay? What you guys did experimentally is you guys figured out what 2 numbers you have here. So you're basically saying how much base do I need to neutralize whatever acid I have. You also get information on what pipette sizes you have. In the practice version, I've given you the same ones that I used in my teaching version, but if you guys do the practice problems that I put on Google Classroom, there are different pipettes and different volumetric flasks, just to kind of make sure you guys understand the concept of what you're doing. What I noticed in particular is that a lot of you guys looked at this one here and you just copied it verbatim from what I had. And for some of you guys, you got away with it because your ratio that you found was, again, still the same ratio that I had. Other people did not get away with this because your ratio was different and then you didn't swap the numbers out properly. So this is what I'm saying. You can't just mindlessly copy what I have done. You need to understand why you are doing it so that way you can adjust accordingly so that way it works for you guys. Okay? So one of the things that you might notice is that these numbers here are in reference to having a 1 and 10 relationship for my actual ratio. So that's where you guys, everything else was actually the same because I gave you the same pipettes, and because I gave you the same pipettes and the same flask, you had the same desired ratio outcomes. These guys here. So that made it easy. But you guys had different actual ratios. So some of you guys had 1 to 11, some of you guys had 1 to 20, some of you guys had 1 to 9, 1 to 8. You had different numbers. And that is okay to have because this is not an accurate method in trying to figure out ratios of acid to base. We are just using it as a means to figure out the method. Okay? So that is something to keep in mind, is that you guys just put in numbers based on what I had as my example, but you didn't actually swap up the numbers correctly. So keep that in mind when you're working, that some of you guys have gotten this table incorrect, and I have noted when you have done that. Okay? Something else to keep in mind is that even if you don't get this table perfect, you can still actually get a merit and an excellence depending on the write-up in the protocol. I'm actually not marking you on this table, is the good news. I'm not marking you on this. This is just showing your work. What I am marking you on is how well you fill out this procedure. So a lot of you guys got not achieved because you didn't fill in the procedure. I had a couple people that did this actually worse, but they filled in the procedure, and they filled in the procedure enough that I could still give them an achieved. So some of you guys did better because even though you did the calculations wrong because you just filled this in. What I'm looking at for over here is proof for the achieved level that you understood you needed to do a dilution. You could have calculated the dilution wrong, but if you showed me you understood you needed to dilute it, I could still give you an achieve because that shows me you know and understand some of the process. So I was just looking forward to see, did you put in some sort of dilution factor and understand you take a sample of that dilution factor and that you understood that there's this sort of color change here. I'm mindful that you wouldn't have necessarily gotten some of these calculations inside correct, but that's fine for the achieved. For merit, I need you to actually do this properly. And in fact, if for the merit you don't show you're working here and you just fill this in and your numbers are correct and it is a valid method, I can still give you merit. So this is just to help you get to your answer, but it's not necessary for your answer. Okay? I'm just trying to give you some scaffolding. So that's what I was looking for the achieved and merit. You'll notice that when I was marking it, I marked it out of either excellence or out of merit. So if I marked it out of merit, it's because you didn't give me the justification. If you got marked out of excellence, it's because you did give me the justification. The justification was, let's move this out of the way, it's annoying me, this stuff here in green. So telling me the why you did something. Okay? I don't need all of this for the excellence, but the more you write, the better, because I am trying to assess, do you understand why you are doing something? All right? If you muck up and you don't do this well, you get a second chance on this in part D. Okay? So you guys write up a proposed method in part A. Part B, you have some calculations to do. Part C, I give you the method that would have worked for this protocol, and you are going to use my method. And that is to ensure that you guys actually can do a proper titration. And then in part D, you compare part A to part C. So the method you created versus the method I created. That is your second opportunity to get excellence for part A, basically. So if you don't get it here, you can get it a second time. I do not recommend just going, oh, I'm not going to bother studying the excellence right now. I'm just going to do it for part D. It's because you're giving yourself one less chance and one less opportunity. So do try to get to the excellence on this part A. So this is one place I can give you 2 attempts, basically. So use both attempts. All right? Questions, concerns, or comments? Are we okay? All right. Keep in mind that for the excellence, and I know I rushed this the other day because we were running out of time, so I'll just recap it. There are lots of different layers that you can have for the excellence. There isn't a set number of how many I'm looking for, but what I'm looking for is overall, do I feel this student understands why we need to do the dilution? Okay? So first off, I would say when I'm structuring it is I think about first off, why am I doing it to begin with? So that's the first question. Why do I need to dilute? So when we do this first rough ratio, what I have done is I have taken 1 ml of my acid, and to neutralize it, I need 10 mils of base. Now, if I was to scale this up for a titration with no dilution, and I times it by 10, because 10 is the smallest pipette size I can use, I would need to have 100 mils of my base to do that. And that's not going to work because my burette is only 50. The other reason why that's not going to work is that I'm going to be wasting a lot of solution. So those are my 2 reasons that I need to do a dilution. Are we okay with that so far? All right. The second thing that I would suggest you think about is why is there an upper and lower limit? So for excellence, the titrate volume, so the volume coming out of my burette, the numbers that are used here need to be between 10 or 25. Remember, there's multiple ways you can do it. So that's why I'm saying you create a method, I give you my method, both of them could be valid, so you need to justify that sort of stuff in part D. So the lower limit is 10, and the lower limit is 10 because our equipment, our pipettes and our burettes have a plus or minus error of 0.2 mils. So when you guys are reading the burette and reading the pipette, there's a chance that you could be 0.2 above or 0.2 below. So that is the plus or minus 0.2 as the error. All right? That 0.2 error is going to have different impacts depending on the size of your volume. So if I had a volume of 10 and there was a 0.2 error, then if I did 0.2 and divide it by 10 and times it by 100, that's a 2% error in my equipment. All right, that's why the lower limit's 10. If, for example, and I know I taught this badly because I was sick. I can tell I taught it badly because I was sick. If I had, let's say I took, for example, we also know that this tenfold dilution, I could have taken a 25 mil aliquot. So if I did 0.2 divided by 25 and times it by 100 as my option, I would have an error of 0.2 divided by 25. So I'm basically trying to see how much error is in that 25 mils. I then times it by 100, so it's a 0.8% error. So smaller error in that one. All right? So that is something to think about when you're thinking about the volume of the titration, the titrate. Okay? So these are both correct answers. I wouldn't go anything lower than 10 because the moment you go below 10, you are going to increase your error. Let's say I wanted to be cheap and I wanted to only do 5 mils and I did 0.2. Well, now when I do that value, that's going to be a 4% error. So it's getting bigger. Okay? Are we okay with that as an idea? All right, so I would talk about whatever titration that you have selected. Make sure you are looking at that titrate volume and calculating out the error in there. Also talk about why you wouldn't want to go below 10. Okay? So talk about the 10, obviously, because that's the lower limit, and then go and talk about your example. All right? Now, I personally, when I made my method, decided to use the 10 mils instead of the 25. So I have decided to accept more error because I want to waste less solution. So the next question is, what is our upper limit? I would not go over 25 because I can do 2 titrations with 25. Because my burette is 50, so 50 divided by 25 is 2. I can do 2 titrations with 1 completely filled burette. All right? Doesn't leave me a whole lot of wiggle room if I make a mistake, but it in theory should get 2 titrations out of it. All right? The less often I fill up it's more efficient to do that. It also means I have to refill the burette less often. Okay? The other thing is that it reduces my waste. So I don't have to use as much solution. So it's cheaper for me to do this option. It's more expensive for me to do this option. All right? So those are things we got to think about when we're doing experiments. Because it's not always about let's do the best experiment. It's also what's the most cost-effective experiment. Are we okay with that so far? All right. Last thing you can talk about is how many times you can repeat that experiment. So think about the stock that you are making. So again, I had 2 chances to make my stock that's tenfold. I could make it 100 mils or 250. And I thought about my experiment and I thought about the size of the aliquot of my experiment. So even though I'm having more error, I can repeat my experiment more times because I'm making more stock. Now, we only want to make the stock once because every time I make the stock, it is a slightly different dilution because it has slightly different error. So it's not going to be too bad. It's not going to make an invalid result, but it is going to hurt my accuracy and precision of my results if I have 2 different stock solutions. Okay? So if I make my stock once and I repeat it, then I feel better about my experiment. So I said if I do the larger stock prep, I divide it by my size, which is 10 mils, I can repeat this experiment 25 times. And so that to me is really good because if I repeat it 25 times, I can be really confident with my data because I can identify outliers very easily. So the more data that you have, the easier it is to check for outliers. So there's no perfect method when it comes to how you design things, all right? There's a compromise somewhere. The compromise that I made was here, my percent error. You might choose that, in fact, I would rather do a larger volume and have a smaller error here and do fewer repeats and spend more money. Okay? So these are all things you have to think about, and this is what we think about as scientists, and this is what we think about in industry as well. Okay? It's that balance between getting good data and not spending a lot of money. Okay? So that's what you need to think about when you are thinking about this assessment. And that's basically all that I have to talk about for you guys. So that's mainly all the issues that I found looking at your work. Be mindful as well, like I said, don't just copy and paste my numbers because you have to swap in the numbers that you are given. Okay? Now, something that I did make, let's see if it's open right now. So when I was marking your work to help make my job easier, something's going on wrong with my touchpad, I think, on my computer. All right, something that I did to help me save my time, because you guys all had different ratios, correct? Yeah, some of you guys had 11, some of you had 20, some of you had 9. I need to very quickly know what numbers you should be having. So what I did is I set up an Excel spreadsheet for me to plug in numbers. So this is the amount of base you used, and I actually set up my equations. Oh, bugger, you can't really actually see what I did here. Let me... Okay, I don't know if I can actually show you guys this in a better format. Let's see. Nope, don't do that. Don't change what I've done. I just want to show you guys that. Okay, can you guys see that okay? Yeah. So, in this box here, I have set it to do an equation for me, and it's just the equation you guys have on your piece of paper. What I told it is take the aliquot, which is 10, this guy over here, times it by the desired ratio, 1/4, which is 1/4 here, and I say divide it by 1 divided by C4. C4 is the amount of base you used. So that way you've already generated a ratio. I had that plugged in, so that way it automatically figures out that that is 25. All right? This one over here, I've slightly changed the number because it's still the same 4-fold dilution. It's still taking the C4 data, which is the actual, but the thing that I've changed is that now I said take the number and multiply it by 25 instead. So basically what I've done is I've created a spreadsheet so that way when I was checking your work and I saw, oh, someone wrote 11, I'll put in 11, automatically change my numbers for me. I'm smart. Let's say I'm marking someone else's work, someone else got 20, I'm plugging in 20, all my numbers have now changed. Yeah? I am happy for you guys to create a Google Sheet like this on the assessment. I'm happy for you to do it right now. Double check your work though, because if you make a mistake and your numbers don't get entered, like if you make a mistake in this formula, the whole thing gets marked. Like you get really strange numbers. So use your logic when you're looking at it. So for example, one of the things that happens when I drag this guy down, you see how now it's suddenly saying I can't divide by 0? The reason why is because it's trying to take from C5. There's no number in there. So be careful when you're making your spreadsheets, if you do want to do this, that you are checking the equations. Okay? I'm not going to put this online because I want you guys to make it yourself if you do want to use this. Okay? Questions, concerns, comments so far? I like how you missed. That was such a clever way to, because I'm doing so much marking, it was faster. All right, let me show you guys what I want you guys then working on for today before my computer dies. That is, well, what are you doing? Okay, classwork. I put it under part A. Under part A, I'll change this. So what we'll do is we'll push this back one day. I'll assess you on Thursday next week for part A. I think that's reasonable. Okay? Don't give me that face. It's reasonable. All right. I have given you guys assessment style questions that you can use for practice. So you don't need to get the equipment out. I don't think you guys in general need the equipment for this one once you know what you're doing. So you see, I've given you the ratio, I've given you your equipment, and then you calculate it out and you fill in this table. In fact, I haven't printed these guys out for you guys. You can edit Cami if you want to put it on the piece of paper. Otherwise, I feel like you can do this on refill. It's not the end of the world. And I feel like this proposed procedure isn't too bad to fill in every time. All right? So there's lots of questions there. And if you've gone through all those questions and you want to challenge yourself, I've put in some extra exercise practices that are super challenging. Not super challenging, different format. Same thing with this guy. I think the last page on here, yes, these are some extra questions for the expert. And some of these here, you have to figure out, oh, do I actually not need to dilute it? And then the other question is, do I need to make the acid more concentrated, is the other thing. All right, so there's some different ways to look at it. All right, that is me. That's all I have to talk to you guys about. Are there any questions? Nope. All right. You guys have the rest of this session to use as study. What time do you guys finish? 45? Do we want? Let me check. 12:40. All right. We got half an hour. I think it'd be worthwhile for you guys to set SMART goals. Yes. You do have assembly. You guys are second half. It's year 12s and 13s and year 11s. I think it's juniors and seniors. It's at the second half, I think. You are second half.
What is in/?
Merit out of merit. So I didn't mark you out of excellence because you didn't have the procedure. So have a think about what you want to work on. If you want to practice your calculations, if you want to practice your calculations, if you want to practice the justification, the E section, or if you want to work on another subject, that's fine. Yeah.